Hello and welcome back. Today we are going to talk about dynamic and interaction visualization, and it is module number 13. But before we start looking at what is dynamic data and what is animation, and I will try to introduce general introduction to R Shiny, I would like to remind everyone this is the end of the semester. So what I will do is next week we are going to have an open session, which means that again, as I invite you to participate next week, I will set a time that we will meet. I will review various concepts and I'll talk about what is the final project is all about, and I will expect you to come up with questions to this live session. So I hope that you will have some interaction with me, so you will have very clear idea of what is expected of you in the final project. So the final project is in this class is April 29 at 12 p.m. And so you will submit your project, and I hope it will be successful, and you will enjoy what you have learned throughout the semester. With that, I would like to start with module number 13. And module number 13 is a little bit more complex because we are going to combine several elements into it. We are in the end of this module, we are going to talk about R and how R has allowed us to produce visual animation. But we will also look at one of the biggest development in R in the last 2 years, which is Shiny. Shiny is a web application that you can run in R, but the problem is that you need to have the backup of R server in order for you to run it. So I don't expect you to produce your final project based on R Shiny, but I want you to be aware of it in future reference. If you will find a job that will ask you to produce R Shiny, you will know what to do. Okay, so again, I think this is the end of the semester, and I need to start summarizing what we have achieved and what we have talked about with regard to visualization. So the goal of visualization can be summarized in three perspectives: the exploration of the analysis, the confirmation of the analysis, and the presentation of the analysis in using visualization. The explorative analysis is the visualize the data, provide hypotheses about the data using the visual that you come up with the data. The confirmation of the analysis is to try to be able to capture your analysis in visualization so everyone will understand what you have done. And the presentation, probably one of the highlights of the visualization, ability to pinpoint what you have done, what you have found, and the visualization is the best tool. Even though we like to use words to describe what we have found, visualization sometimes overcome that and be able to transform that into larger scale or larger audience. So the comparison of the ability of human and computers, I did not talk about that, but again, as I think back to what I have started, I want you to have a better sense of what we are in and how we are be able to do what we are doing with regard to visual analytics and with regard to what we are able to do. So we did not talk about capabilities of the computer: ability to store data, ability to search data, ability to compute and the analysis for us. But we in that order, we also need to talk about human ability. What is the creative aspect? What is the general knowledge that we have that we will be able to match them in order for us to have better understanding how we can compare computers versus humans with regard to analyze, diagnostic, and planning the analysis. But before we will discuss in interactive techniques or the dynamic techniques. I would like to provide short review on animation. Why? Because history it's really important to learn history in order for us not to make the same mistakes. And one of the things that if you will go back to the literature about interactive and dynamic, most of those developers were based on animation. They took the animation as part of the foundation of the interactive or dynamic techniques, and they apply that into visualization based on the history of animation. So that's why animation is so important for us to understand. And again, it's given us the ability to have the vision that we are using interactive components in our analysis or in our visualization. So the term animation, the term animate is to give life to, which means that we are trying to give life to a character or a thing, and we are trying to do that by moving it or by providing space to it by using tools that will allow us to show that. So there's two main categories in animation. There is the computer assisted animation, which is the 2D, the in the twin, the link, and the virtual camera. And there is computer generating animation, which is a low level techniques and a high level techniques, and both techniques are being used. I will show you today, I will show you with regard to R, a low level technique that allowed you to create animation in R. But this is not the end of the story, because we also need to know how to create a high level techniques to describe the motion behavior. So in low level technique, we are talking about in twin, which means that you have to know what you want. And by doing that, we are creating a keyframe that together with the animation will create the feeling of one animation going through. So it is the idea that we will split each keyframe. Keyframe is the idea of one particular element, example 1 or 2 or 3, and then together we will combine them into one and add the animation to it in order for it to be produced. I will show you an example of that. In R. This is our simple animation, and again, this is the idea of a simple animation that allowed us to do that. High level is a little bit more complex, because we need to create something that R still do not know how to do well in compared to 3D Max, which is ability to create 3D animation object, and then do the object be able to animate them in order for it to get into motion. So this is a different approach that is in R still do not exist, but it is important aspect that you need to know. In abstract, the animator color each pixel in order for us to make the movie about a dog. So we are using each pixel to color it and to create that illusion that there is something going on with a dog. And we have the playback, and we have a sample or update rate. And usually when we are talking about TV, when you see animation in TV, we are talking about 30 images per second. And there is 6 different images per second, and each image repeated 5 times in order for the animation to create this impact that we think there is something going on in the background that makes this animation. if you have an old your not parents but grandfather animation book, you probably will see that there is a book that shows the animation through flipping the book and be able to display that. If I was in live session, I probably will show you those type of books that when you flip that, there is the idea of showing the animation, the object moving from page to page, that we are flipping it fast. So there is a lot of history on that and how they apply that. And again, it started quite early. It started in 1857, and they started to apply that in order for them to tell a story. And this is important because in the end of the day, even now, we need to tell a story out of our data. So again, in 1995, Thomas Edison created that, and he tried to use this idea in order for it to create the first animation and be able to display that in a sense that give us a sense that there is a story behind these images, moving images. There is a lot of history of animation, and I'm not the perfect person to talk about that, but I want you to have appreciation to animation, and I want you to have appreciation that this is something that is really important, because this gives you a sense how this community, the visualization community, apply the principle of animation into our visualization in order for us to tell a story. So we have in the idea of the history of animation, usually what they did was have lips and hands and body and cards and road and sky in order for them to create animation using their device. And this is a storytelling in the structure of how they apply that. So there was the idea of how to set the scale, how to set the layers, and how to allow to have a grace scale into it in order for it to make it concise throughout the idea. The heritage of animation, again, we can talk about all those innovators in animation, from Max Fischer to Paul Terrier, and how they all build into animation to tell a story. And of course, is Disney World, and how they apply animation to tell a personal story out of it. And Walt Disney just created an empire out of animation, and they used to have a storyboard to review the story, a pencil sketch to review the motion, multi-plan camera to capture this animation, colors, and sound to tell the entire story or the entire narrative. So the camera was in one place, but they used to move around the places that each cell is located in order for us to make the users believe that there is something more moving on, even though in reality nothing moved on in the background. Warner Brothers, MGM, it's all about animation. It's all about how to apply animation to do that. And again, computer animation is often compared to stop motion animation. And if you do not know the frame, what is stop motion animation is the idea that we are stopping the animation in order for us to make the user believe that there is something going on and there is some motion going on in order for us to do that. So there is a lot of techniques that involve in it, and there's a lot of I will not go over because probably it will take me forever to finish this idea of animation. But again, I want you to pay attention to it. Clear animation, pinhead animation, sand animation. If you will do some search, and I encourage you to do that, what is clay animation, what is pin animation, or what is sand animation, you will learn how those techniques become a very popular platform for any animators and even any visual analytic person, in order for them to manipulate to the image capture and do a repetition in order for them to do that. With regard to the storytelling itself, they used to have a structure: the presentation, the act, the scene, the shot, the frame. All of that was part of the schema of how they generate the animation. And again, everything was on the pipeline in order for them to do that. The computer animation as animation by itself, again, this is when they started to work on Walt Disney before it becoming Pixar, and this is where they started to use computers in order for them to generate. And there was, during the 1980s, 60 to 1980s, there were a lot of labs that did computer animation. And one of the animation that was creating was the idea of display the animation, generate the animation, and learn about what the animation stands for. And there's a lot of existing labs. An example, the University of Utah is one of the biggest animation lab in the country with regard to academic animation. And if you are into it, I highly recommend that you try to see what they are doing and how to work with that in that hands. So again, the history of computer animation, 1974, Peter Folds and René Join did that and tried to tell the story of the computer animation. So again, current, I just highlight some activities. The Toronto Computer Science Department has a big animation center. Georgia Tech has a big usability center. Ohio State also have 2 labs that are working, and I hope one day I will be able to get the funds to create animation or bring people that is specialized in animation into USF. It's still an ongoing process, and that's what I do on my daily basis, search for grants in order for me to bring it. So the idea of history and film and video, many companies entail that. I just want to just let you know about what they do. They have a lot of companies that do that, and all of them are trying to come up with it. Disney, Pixar, Apple also is really into animation and how to tell a story with animation. So you are in the right path if you are in passion with regard to visualization and what they do with that and how to do that. CGI is also part of the early development in the stage. And again, I encourage you to take this PowerPoint. I share this PowerPoint for you to search about those companies, see what is morphing video is, what is like to do that in computers, and how they revolve around it and how to apply that. So again, we see a lot of TV animation and how they apply that, and this is part of the resource about the milestones of animation in the 20th century and the brief history of computer lab. Back to our subject and back to our interactive and dynamic visualization. And what I will try to do is I will talk about what is the technique itself, and I will not go over every single technique, but instead I will highlight techniques and I'll encourage you to go and search for those techniques. So the idea of interaction technique is the combination between hardware and software to provide a way for a computer user to accomplish a single task. For example, when you open your browser, you have the ability to go to the next page or to go back to the search engine, or to go back and you are using a mouse or and keyboards in order for you to has this interaction with the visualization or with the software application. It is part of the nature of the human computer interaction in terms of it's a new interaction technique, and we often talk about that. I'm not an HCI person per se. I'm more about the pragmatic aspect of HCI. So there is a lot of techniques in HCI, and one of them is the ability, how do we introduce a new interface design to a new users? Microsoft often use it, Facebook use that, and even Google use that quite often in order for you to do that. The problem that they are facing in HCI is that we have three point of view with regard to how we see interactive. The computing view, what is the input in device that we are presenting this information. The user point of view, again, the user can have different backgrounds. Example, my background is different from yours. And the design point of view, what is the design objective? How do he accomplish those design into the interface or the interactive interface in order to meet the user point of view, and the computing point of view is the input device. So those techniques has to come up with data to the visual mapping, and there's a lot of techniques about it, AutoVisual, S+, C, Gobi, and so on. There's a lot of projects involved around it. And all of those projects is becoming productions and becoming a real something to follow with that regard. There's also issue the filtering. How do we filter the data in order for us to fit into what we are searching? So there is the selection, and there is the idea of the quality that we are trying to achieve, and the idea of linking and brushing, again, how to match those expectations, and the idea of zooming in and zooming out of the data in order for us to give different perspective. We will see that in Shiny, that allowed the user to zoom in and zoom out of the data in order for them to see what is out there. And there is also detail on demand, depends on the details that the user asks, and based on it, frame or create a new visualization that will fit the user perspective. So there is a lot of issues nowadays with regard to projections, interactive production that remains in 2D or 3D, and there is a lot of automatic version result in animation of the data. How do we animate the data, and what do we do with it? The filtering, and as I said before, filtering is becoming very important. And the filtering is the filtering of the data. How do you filter the data? Do you make a distinction between them? And when you are in the interactive space, you have to make a distinction between selection and query, and by ability to specifically point out to specific problem with ability to search for those conditions in order for it to be met. So this is the idea of filtering, and I want you to have that as a framework when you are thinking about your project. Okay, so animation and all. And I know I'm jumping ahead of myself, but in this model, I will use one of the founders of one of the founders of RStudio, and who works in animation, he created his own website that talks about the idea of taking the animation. So as you can see, what he did was the idea of taking animation, simple animation, and show the users by animation where is the scale of data going through and what does it mean. So he provides all the animation, the package that he created called animation, and nowadays he works at RStudio. There is also the blog posted by Brian about animation, and it is from our blogger that will show you how, first of all, how to save in order for you to display animation in image. You have to save it as a GIF, not as a JPEG or other format, because GIF is the ability to save it as animation, and he will go through his code to show you what is it entail. So this is the idea of animation. But I do not talk about one of the things that I really think that needs to be addressed is the idea of Shiny. And what is Shiny? Shiny is a web application that basically runs on a server that is connected to R. And as I said before, it gives you the idea that it gives you the animation, it gives you the user the ability to search what is it entail, it gives you the ability to select and to resize the factor in order for you to apply and to display that and develop it. So there's a lot of animation example of it. The problem in academia with regard to Shiny is that, first of all, it costs a lot of money, and usually academics do not have the money. Second, it requires that everything will run on the R server, and there is an R server nowadays, and so this is something that is really hard. And so the option for academia is maybe to join the RStudio developing of the RStudio server, or to provide something that will support the development. Something that, if you are interested, I will be able to help you to connect to the right people. So this is the idea of the Shiny, and the Shiny also give you a lot of how to build, how to improve, how to share those documents. So this is the idea of Shiny. I know that I gave it 2 seconds, but this is what I want you to take out of it. This is the new development. Shiny came out only last year. It still needs a lot of improvement. There is the issue of code quality that's still not been tested, but again, you can take what you learn in RStudio and apply it to the Shiny, and it most likely to run. So this is all I have for this module. I hope you enjoy it. I hope you learn about animation a little bit. There will be no assignment, because one thing I want you to start thinking about your final project. I want you to think about what is it entail. If you have any questions about animation, please let me know, or please open the PowerPoint presentation and do search on the key terms that I used, and try to explore. I will provide more information about animation and interaction, visual interaction, articles that I like you to read. Until next time, have fun.